Hello. Today we are going to start with the fourth lecture of the second unit of survey engineering. Okay, that is of surveying. It is triangulation. Okay. So what is triangulations? Classification of triangulations and the principles of triangulations. So this is what we are going to study in the triangulation part of this lecture. Contents of today's lectures are triangulation, what really does triangulation means, okay, that is definition, principles means on what basis the triangulations are being decided and on what basis it suits in the surveying, so how it is useful. These are the things we are going to study in today's lecture. Okay, triangulation. See, triangulation is nothing but arrangement of triangles such a way that we cover the required area or considered area in a portion of network of triangles. It is nothing but it is a network of triangles connected each other by the adjacent sides of a triangle. Right? If you can see here, the triangles here are a network with its adjacent sides. Right? So in this way, we are going to cover the area so that we will come to know the distances, the area, and also we can get the details of those areas in minute inner details of those areas, right? So this is what we call it is a network of triangles which are interconnected by the adjacent sides of a triangle to each other. By this we will cover larger area, okay, and there will be no cumulative and compensative errors if we start from the boundary areas and get inside the internal areas, right? As we know, the principle of surveying, that is first principle of surveying, that is work from whole to part, right? From the whole we are going inside the area so that we will cover the larger extent and we don't have any errors in it. Triangulation system consists of number of interconnected triangles in which of the one of the line is called as baseline and the angles of the triangles are measured very precisely, used to establish the horizontal control systems for a country. Now, what does this really mean? We know that triangulation is nothing but it is a network or number of interconnected triangles in the length, okay, and one of its, if you are when you are starting with one triangle at a start, right? So when you start, you should have a baseline of a triangle and whose length is known to us, right? And whose length is known to us. Then we are going to project the other two sides and we have to calculate or the measure very accurately the angles between the two sides of a triangle, right? That is what it is saying. It is saying that what is triangulation? It is interconnected network of triangles, right? That is what is a triangulations. In this, one base of the triangle, the base line of the triangle should be known, whose length should be known. And when you convert that baseline into a triangle, okay, that the angles between those sides of a triangle should be measured precisely, okay, and used to establish the horizontal control systems of the country. Means what? This here are you can understand two things in this point, that is this is considered for a larger area, it is not considered for a smaller area. We are considering here a country, so it is a large area. So this triangulation is mostly used in the geodetic survey. It is mostly used in a geodetic geodetic surveying, right? Where the larger area is considered, where the curvature and the refractions are considered in that area or that part of surveying, you are going to use morely the triangulations. What are these horizontal control systems now in the country? These are the control points or the main points through which where we know the RLs and also we can start the surveying itself. Okay, those might be outside the country or it might be inside the country. It might be on the oceans also. These control points can be set up on the where those are our main boundary lines, right? It is the main major lines or the control systems on the borders of the country, right? It might be a sea border or it might be land border. It doesn't matter. But when considered about the control systems, that these are nothing but the main points where we consider a major outline of the surveying systems. Okay, when you are going to do the survey or triangulations, we are going to set up the boundary lines first, right? So these boundary lines and the stations at which the boundary line starts, at various points there might be various boundary lines, right? So for them there are various stations. For that station we call it as horizontal control points, right? Now principles of triangulation. First principle is the entire area to be surveyed is converted into the framework of triangles. The, the entire area to be surveyed is divided into small triangles and which are connected to each other. What it is trying to say, right? As it is said in the definition also. If the length and the bearing of one side and three angles of the triangles are measured precisely, the length, the direction of other two sides are computed. So in this case that we know that the base is measured and the angles between the sides of the triangle is also measured very accurately. And if it is measured accurately or precisely, then we can calculate, okay, we can compute the lengths of the other two sides, okay, and its direction. Okay, so we'll go for the third point. You understood? The what definition itself says is been deeply explained or is been given into the deeply explanation is given into the principles, right? Next is the method of the surveying was first introduced by Dutchman Snell. Who he was? His name was Snell, and he belongs to which country? Dutch country. So he is called as Dutchman. Keep this point in the mind. This might be asked as a in the quiz of your assignments or in the activity, right? So just remember this. Precisely measured lines is called as baseline, right? Now what is baseline? If we go through the explanation, if you want to start an survey of any area, we'll first put a, because we have to start with a triangle. Start with the triangle, we should have set a baseline or the major line, you can say it. On that line we know its accurate length, okay, then we will set up a triangle here, right? Then we know this length L, we know this angle theta 2 1 and theta 2, right? So when we know this, we are going to calculate the direction and length of this side of triangle, right? And the precisely measured length of a base is called as baseline. The precisely measured length of a side of a triangle. Remember this, there are two terms, that is measured line and computed line or calculated lines. One is the baseline that is going to be measured, so that is called as baseline, what it is trying to say. Compute two lines are used as a baseline for two interconnected triangles. Now what he is trying to say here is that once you, this is a baseline because which is a measured distance side, right? So once you measure this, you determine the, or you construct the triangle, then you measure this distance, right, with the help of the three angles, right? Now once you know the length of the sides, this becomes the baseline for other triangles, right? This side becomes the baseline for other interconnected triangles. Then again you measure the angles of it, because you know the distance of this baseline. You will measure the angles precisely. Then you will calculate the length of this sides of the triangle, and these sides will become the baseline for the other triangles. This will go on till you complete the whole area. You understood what he is trying to say? Next point is, vertices of the individual triangles are known as triangulation stations. The horizontal control system stations are different, and the triangulation stations are different. And how they are different? These horizontal systems are far away from each other. Okay, these horizontal control systems are far away from each other in kilometers. Hundreds of kilometers they are far away from each other. But the triangulation stations are very much nearby, because each triangle vertices will be having these stations to control the baselines and its measurements, right? Next is, extending process of network of triangles can be computed over an area. When you continue this process of converting or constructing of triangles over each other by connecting each other, you can compute the whole area. Once you cover the whole area to be surveyed, you can easily calculate the area and the dimensions of those areas. Okay. As a check, the length of one side of a last triangle is also measured and compared with the computed one. So once you complete the interconnected triangles, the last triangle, okay, when you come to the last triangle, you will compute the, or you will calculate the length of the that triangle. Okay, once you compute it or calculate it, you will go and measure it actually on the ground, so that you will have to check whether the computed or the calculated dimension is equal or it is same as that of the measured distance on the triangle. Okay, that is what a check you're going to do on the last triangle. Subsidiary bases are measured at a suitable interval to minimize the accumulation of errors in the lens. So what you're going to do, in between, when you complete 10 triangles or 15 triangles or set of triangles are interconnected, then you're going to measure the base length and also calculate it or check there itself, so that this error, if there are errors, they should not go on accumulating and increase the error. So for that purpose, you're going to subsidiarize the base and check whether the bases are the baseline is correct or not. Right? The astronomical observations are made at intermediate stations to control the errors in the azimuth. Those triangulation stations are called as Laplace stations. As I said, these stations, horizontal control stations, are very far away from each other in kilometers together. That is also hundreds of kilometers together, far away. It might be on the oceans or it might be on the land fronts. If it is on the land front, it is very easy to get the some reference points. But on the ocean or on the sea fronts, you can't get the reference points. So in that cases, you have to take a reference of the astronomical bodies. What are the astronomical bodies? The stars, the moon, right? These stars, various stars, become your reference points for the control station points, or to check whether you have done any some errors in the calculation or formation of triangulations, right? This is all for today's lecture. We understood what is triangulation, right? What is triangulation, and then we saw the principles of triangulation. That was how the triangulation is to be considered, what is the measured distance is called as, how the two sides are being computed with the help of the other three angles of the sides, okay, and the one side length, right? What it is called, who discovered or invented this type of surveying, okay, and then when there is no reference points, then how you are going to have reference points. Example, in the case of oceans where you don't have any reference point nearby to you, you have the whenever your eyes go at whatever distance it goes, there is a sea around you. So in that case, you are going to take the reference of the astronomical objects, and how to check the errors into the triangulations, and how what is the use of these triangulations to calculate the area, to get the details of the area. So all these things you have studied today. So in the next class or in the next lecture, we will be studying about the purpose of the triangulation and the classification of triangulations. Okay, thank you.